Yes. So let's start the day today. So guys, back with another video. I think I need to do some settings, customization, reaction. Okay, there we go. So topic for today is going to be learning the performance optimization on the website. So this is important as a front-end developer. If you are developing websites, you should know that why performance matters a lot. And so I don't have anybody right now, so I just study together. So I'm just having the stream is open right here. So I'm just making sure that nothing breaks. Apart from that, let's read the article one by one. So it's probably going to be a 1 hour session or 1.5. Let's see how it goes. Hmm. Just a minute. I don't know how to pause the stream, so doesn't matter. Okay. Before you can get started with learning points, you have to first understand its role in the user experience, how it can result in better outcomes. User, this course starts off with a brief introduction into these topics, giving vital context as to why it's important to learn performance. So let's read the first article, what it says about performance optimization. So why does speed matter? Consumer increasingly rely on web to access digital content and services. If you look at the website analytics, you can probably see this story playing out your own data. Consumer likely demanding than they are been and they're experiencing your websites. They aren't only comparing you with your competitors, they are rating you against the best in class services they use every day. This post round up some of the research that has been done on the relationship between performance and business success and why speed is one of the defining factor in how successful online ventures can be. Performance is about retaining users. I totally agree on that actually. Definitely. If your website is not performing, has a bad score, has bad web vitals, then definitely not many users will come back again to visit your website. So, that being said, at Google, we spend considerable amount of time and effort defining the set of user-centric performance metrics known as core web vitals. So those of you who do not understand what core web vitals are, so these were given by Google, guidelines, you can say, sort of guidelines that you as a developer should be aware of. So this contains, let's just read this out. With this backlink, we actually visited the web vitals now. Let's just have the overview. Web Vitals is an initiative by Google to provide unified guidance for quality signals that are essential to delivering a great user experience on web. So Google has provided a number of tools over the years to measure and report on performance. Some developers are expert at using these tools, while others have found abundance of both tools and metric challenge to keep up with it. That shouldn't have been performance experts to understand the quality of performance they're delivering to the user. The Web Vitals aim to simplify the landscape and focus the metric core web vitals. So let's understand core web vitals one by one. And I've actually already visited this blog once while I was in Karwale, but I'm visiting this again because I'm actually looking for a switch. So core web vitals are the subset of web vitals that apply to all web pages, should be measured by all silent owners and will be surfaced by Google Search. Each of the web vital represent a distinct facet of user experience in measurable in the field and reflect the world experience of a critical user-centric outcome. The metrics that keep up with basically these are the metrics. The first metric is largest contentful paint, measures loading performance to provide a good user experience. LCP should be within 2.5 seconds of when the page first starts loading. So to give you an example, what I'm going to do is I'm going to visit Lighthouse, Google Lighthouse. I think, yeah, PageSpeed Insights. Yeah, this was the website. I'm going to enter HTTP and I'm going to type carvale.com. So this was the old website that I that I used to check. Let's see uh, what is their page performance. And yeah, their core web vitals for mobile has failed, and it is that is fine. We just want to check for the desktop version for now. So LCP for the desktop, because uh, this might be testing, this entire test is been ran on a device, might be a desktop, and for mobile, the Carvel specifically has some different type of loading. I mean, if you go from if you visit that website from mobile, the loading might be different than the way desktop works. So the entire build is sent differently. It's like that. So the first contentful paint that we are seeing is 0.5 seconds. The largest contentful paint that we are having is 0.8 seconds. And the total blocking time is 660 milliseconds. CLS is 0.001. So there is no layout shift actually, and there is a very minimal layout shift. And the speed index says it's 1.7 seconds. And I don't know if this has a waterfall model to it, but definitely there was this website I used to visit, GT Metrics. You just go there and see what's the performance there. And I'm just going to type, uh, I don't remember if, okay, let me just log in, because I think they have logged many things on the login wall. So let's just visit this website and see. Yeah, GD Metrics Pro plan. What are they? Okay, we don't care actually. Just for, okay, so they have shifted the on-demand test. We've reached the on-demand test. Yeah, so I cannot test any further for this. I think, yeah, let me just log out, so it's no use. Just type carvale.com and see if we are able to test it out. I could actually make a separate email, disposable email, and try that out from that, but if it doesn't work this way, then I'll probably do it. And let's just see. Till now, I'll just prepare the disposable email. Just going to type temp email, get the disposable email. Mm, yeah, there we go. We have a disposable email at our, and this is still generating. Just wait for 2 minutes and see. Till then, what are the other metrics that we have there? So we have LCP, we have INP, interaction to next page, CLS, we have first contentful paint, and time to first byte. So performance wise, the this particular website is ranking at 72, and I don't know how they are calculating the score. The performance score is calculated. You can visit and learn about how the score is getting calculated, to be honest, and what are the weightage that they are given to the website. But there is one particular section that first contentful paint, speed index, and these are the first few weightages. And CLS has a weight of 25%. So these are the total blocking time is 30%. So if you are running a JavaScript file, and that JavaScript file is blocking in nature, that uh, it's taking too long to parse or something like that, then you're going to definitely have an impact on your website ranking. So this actually decides how your website is going to rank, and it's special. And every developer should be aware of this. So reduce JavaScript execution. That is the first suggestion that it's giving. Minimize the main thread work. So mainly the script evaluation, parsing, compilation is done in this particular phase. So we can avoid that as well. So, and it's also saving that images are not properly sized, estimating 4 KBs worth of savings we can do there. But to be honest, Carvale's image optimization is the best I have seen in any website till this date. I mean, I've not visited any website that has better image optimization than Carvale. Not even Amazon, Flipkart, none. So I think kudos to them, kudos to the front end team, kudos to the backend team as well. for developing such an awesome site. So let's just get back to uh, the GT metrics and see if this was reported. Definitely we can see. And yeah, everything is just logged under. So let me just create an account for now. So random, and let me just give, I'm just going to type password at the rate 123. You can change this out. Password at the rate 123. Let's just go password at the rate 123. So yeah, let's just visit this website. We have GT metrics. There we go. Validate my email address, and let's just see login. Okay, did I miss something up? Let me try password at the rate 123. Login. So yeah, it has logged in, and here we can see a lot of metrics that was not visible in Lighthouse. This is the reason I wanted to create account here. So as you can see, we have time to first byte. That is when we received the first byte, and first contentful paint is right here only. That when the layout started to paint, and the onload time is 2 seconds. And time to interaction 7.3 seconds. I do not understand these terms quite well, and so that is the reason. The next thing I'm going to do is just visit Claude for help. So are these in okay? These are the metrics, right? I'm just too lazy to copy paste. So let's go back to Claude and see uh, what does it mean. Can you help me understand these concepts via a good example? Keep it simple. Keep it simple. So let's just go and ask Claude Sonnet about this, and it should able to give us a pretty good idea. I'll explain this web performance metrics in simplest analogy. So when the main content becomes visible, restaurant example, you walk into a restaurant and the time it takes until you see the menu on the table, not just the doors or walls, but the actual thing you came for. The menu with food options, good score. Nope. Also provide with respect to, with respect to analogy. Also provide with respect to analogy. Let's see what it does. So you click on an article link. Uh, LCP is when the main content image headline finally appears, not just the header logo, but the actual content you came to read. Bad example. Visiting a blog where you see the navigation bar instantly, but the actual blog post takes 5 seconds to show up. So there might be a loading spinner or that. Does that count as LCP? Within the LCP, I don't think so. Interaction to next paint. So with respect to an e-commerce site, you click add to cart button. INP is how long until you see the visual feedback. So I understand the INP because Google has recently released this particular metric, and what it basically means is you visit this website, let's just say carvali.com, okay, and you click on some action. Let's say you clicked on used or you click on new. So whenever you click on this particular button, when how long does it take for us to see the visual feedback? In this case, this particular pill is going from left to right, right? That's a visual feedback, and that actually is an INP. So interaction to next paint. So it should be very low for your website to rank. So this marks actually 25% of of your entire metric chain. So be aware with this particular metric. So I know this because I worked with this fixing the INP issues in Carvalho. So next thing we have is CLS, cumulative layout shift. With respect to a mobile website, you're reading an article about to click read more. When suddenly an ad loads at top, pushing everything down, and you accidentally click on different link. So the best example that I can give for this is you loaded a website, and after loading of the website, there is a layout shift happening. So let's just say this is the website, and initially we do not have this banner. We do not have this entire banner. And when the website loaded and we do not have this banner, and after let's say 2 seconds, we got this banner. So the entire layout, the bottom layout, the find your car was like this. Let me just show you how, what do I mean by this. Uh, just go back. So this is right. So I'm going to just delete this entire stuff. So your website loaded with something like this, and after 2 seconds, this loaded. Okay, after 2 seconds, this particular thing loaded, and it shifted your entire layout. So how bad was the shift? That is what is being calculated by cumulative layout shift. That is 0.02. Uh, that I understand correctly now. First, contentful paint. With respect to any website, the moment you stop seeing a blank white screen, even if it's just the logo or background appearing, something is visible. Bad example, blank white screen for 3 seconds before nothing shows up. Uh, okay, I do not understand this quite well. I'll probably ask again. Time to first byte. With respect to you type a URL and hit enter. How long before your browser receives the first tiny byte of data from the server? Like a packet ship notification. Bad example. Slow server takes 2+ seconds to acknowledge your request. So this is pretty simple. Time to first byte. It actually is not under your control, but it is under the hosting's control. So if you are using Netlify, it's their responsibility how fast they're shipping your code back to you, back to the user's request. Let's just say user created a request. So this is me, and this is, let's just say, client. So client hit the Netlify server. So let's just go back, and this is Netlify. So client requested code, it went to Netlify, and Netlify is going to respond with some time, right? So this delay is what time to first byte is referring to. Time to first byte. So this is it. I mean, the response that client is going to get. If I'm not wrong, I might be wrong. So if I'm wrong, just correct me out in the chat. And the next thing is first contentful paint. With respect to any website, the moment you stop seeing a blank screen, even if it's just the, I do not understand this metric. So can you deep dive in this topic? FCP measures the time for when the page starts loading to when any part of the page contains is visible. Text, even a single letter, images, including background, SVG graphics, loading spinners, usually iframe content, background loading alone. Okay. So FCP is basically when you got the first good thing to see. Like if you're just seeing the spinner on the website, it is still not counted as FCP. I mean, not the first contentful paint. So if after that spinner is loaded, let's just say you visited a website. Initially, there was a loading spinner, and after some time, you got some animation, some video, or something like that. So that when did you get that animation or that video? That is what FCP means. So I cannot explain you in simple terms. So this is what it means. Navigation starts, time to first byte from the server, exactly. First text image appears. This is what the FCP is. So after that, largest contentful paint. So largest contentful paint means your website is completely rendered. So it might happen that your website is loaded and it looks something like this. But at bottom somewhere there was this animation that didn't load, and that is going to count under the LCP, largest contentful paint. So with that down, we understood all five metrics correctly. And actually, I used to remember these, but I forgot a while. So now it's just a revision for me. So let's just get back to the life cycle. So we understood the life cycle as well for this. And I don't think so. We require to read this out later, because the core idea was to, okay, let's just read the life cycle. Metrics on the core web adult track go through a life cycle consist of three phases: experimental, pending, and stable. Each phase is designed to signal to developers how they should think about each metric. Experimental metrics are minimum testing and community feedback. So there are three types of metrics, and it's first is experimental, second is pending. There are past the testing and feedback stage and well-known timeline to becoming stable. And there are the third one is the stable metrics. So LCP, CLS, and INP, these are all stable metrics. And there are some metrics that first input delay, interaction to next paint was experimental, and then I think it was added to it. I'm not going to read this out, but I think that is what it's saying. Pending. When the Chrome team determines that an experimental metrics has received sufficient feedback and proven sufficiency, it becomes pending metrics. For example, IN was promoted to 2020 experimental to pending status with the intent to eventually retire FID. First input delay was okay. It's a successor to first input delay. That's good to know. Didn't knew that. And the stable is basically their release step, how they release stuff in terms of metrics, how they decide when which metrics is available for websites. So so basically Chrome uses this, Google uses these metrics to judge how fast a website is loading, and your website slow is loading slow, then they are going to derank your website, and this is how your website score is getting calculated internally. So that is the reason why we are learning, because we can apply this in our next job or whatever is required. So let's just read more. So in this, uh, I want to actually add one more thing, that in this dashboard or the lighthouse score that we got, we actually had this reduced JavaScript execution time, and I think excessive DOM size elements. So first of all, if you know about DOM, anything about DOM, it's quite complex in nature. First of all, we'll deep dive in DOM in next video or something, but let's just first understand that by excessive DOM, it really means that you're using more divs than required. Let's just say that your component, whatever you are using, let's just say you are rendering a card, and that card can be rendered using some tricks, or some tricks that you can do with CSS. And if you can avoid multiple divs, nested divs, you should avoid nested divs. And if you don't have, let's just say you're using one component, you're rendering one component, and that same component is being used multiple times in your website, then that one div that you added is going to have a cost of multiple renders. Let's just say in this particular Carvale website, this card is loading about n number of times, right? So if I messed div for this, if I let's just say if I open if I inspect the element, and let's just say the this was the div that it is getting rendered, and inside this div we have an image. So basically only two divs that okay, inside the div we have another div. So this div is going to get added to every single element, every single card element, and that is adding the cost. So if you're able to reduce the cost of one additional div, you're saving a lot of your website re-render work. So that is going to amplify actually. So let's just get back to the page speed index. So this is done. When we started learning, ठीक है. So we read the article why speed matters. Now we have not completed. We only completed the web vitals. And I think below are okay changes to web vitals. We don't really care about the later part. So what's the next thing we want to do? page speed. Why does page speed matter? Page speed does matter a lot. And okay, general HTML performance consideration. So this is a short blog. Let's just read it out. First step is in building a website that loads quickly is to receive a timely response from server for a page HTML. When you enter URL in browser address bar, the browser sends a GET request to the server to retrieve. The first request for a web page is in form of HTML resource, ensuring that HTML arrives quickly with minimal delays in a key performance goal. The initial request for HTML goes through several steps, and that is what we saw, reducing the time spent on each step, giving you a faster uh, time to first byte. The time to first is so not the sole metric you should focus on when it comes to how high it does make it challenging to read decimal good threshold for the metrics, CP and FCP. So I also wanted to show you the waterfall model actually. If you go back and let's just see the performance uh, metrics of this particular stuff, and if we can see that it gives the clear indication of the metric, and it is showing this is the waterfall. It's going to generate a waterfall model that how what is blocking and how long did it take for everything to render, and why is the uh, time to first byte and everything. So this is the timeline, and after that we do not have any asset after this particular time. So that it is, you can see clearly that how the entire DOM was loaded. So core web vital assessment, it has showing failed because of INP and the time to first byte. Pretty bad stuff they are doing there, maintaining it. Time to first interaction is so bad, and structure wise it's fine, history wise it's fine. And I think that sums up what we wanted to actually say. So let's close this website out and let's just go back to this. So minimize redirects. When a resource is requested, the server may respond with a redirect, either with a permanent redirect 301 or temporary one 302. Redirect slow down page load because it requires the browser to make an additional to add the new location. The two types of redirects, same origin redirect that occurs entirely within your origin. These type of redirects are completely within your control, as the logic for managing them resides within your web server. Cross redirected by another origin, these are typically out of your control. Cross-origin redirects are often used by ads, URL shortening services, and other third parties. So, one good example that I can give you right now for the cross-origin redirect is if you visit x.com. Earlier it was twitter.com, right? So let me just try twitter.coms and let me go to my profile, put with Kai underscore. So technically this should work because Twitter and X share the same origin, not the same origin, different origin, right? So let me just return, and it redirects, right? That minimal redirect that is happening, that the time it is taking. So that is a redirect, right? So we want to minimize the redirect as close as possible. So either is the same origin redirects enter within a website. So let me just ask this out because where was it? Okay. In context of twitter.com and x.com. Earlier, I used to access twitter.com/my profile with Kai. Now it redirects to x.com/with Kai. Does it count? Does it count as cross origin? I think it does count as cross origin. I'm just confirming. I don't want to learn anything wrong. So let's just read this out, whatever it says. Protocol plus domain plus port. Twitter.com are different domains. So yeah, that is a cross origin redirect. Origin is different of three parts: protocol, domain, port, and different origin. We have different origin definitely. But wait, what? Who controls it? So we don't really care about this stuff. So it's fine. Let's just go back. We got my answer. So basically, we want to avoid having redirects if we can. So if the website is moved, then definitely we have to redirect that. In the case of x.com, we have, but we don't have any choice but to redirect from twitter.com to our servers. uh, Cache HTML responses. So if anyone does not understand why the delay is getting added, it's more of this diagram I can show you. So this is Twitter. Let me just give Twitter. This is x.com, and this is the last one is going to be client. Let me give client, and client actually want to access his code. So what happens is, if you type twitter.com, it is going to first go to the Twitter, and the twitter.com is no longer there. Back. I suck so bad at Excalibur. Let me just try again. Yeah, like this. And then the request is going to go to the x.com. So the redirect that it took two steps, right? One additional step, that going to the twitter.com, then finding the origin for the x.com. So that is adding the delay. That is what I meant. So let's just go back. Caching HTML response. Caching HTML response is difficult since the response may include links to other critical resources such as CSS, JavaScript images, and other types. These resources may include a unique fingerprint in their respective file names, which based on the file's content. This means that your cache HTML document may become stale following a deployment, as it would contain references to outdated sub resources. Nonetheless, a short uh, lifetime rather than no caching can be benefited, such as allowing a resource to be cached at CDN, reducing the number of requests that can be served from origin server and in the browser, allowing resources to be invalidated rather than downloaded again. This approach works best for static content that uh, doesn't change in any context. An additional appropriate time to cache the resource can be set. Okay, so we basically want to configure the cache and the cache lifetime, and this can be done by using etag or last modified header response. That is what it's saying. Etag, otherwise known as entity tag header, is item that represents the request resource using a hash of the content. I do not understand how caching works, to be honest, in the browser. And I used to understand, or I didn't learn it quite well. So it's time to correct my mistakes. Just go back. Can you break down this concept for me? Mm, I'm confused about request header part and configuration of e tag and last modified. So let's just read it out. Let's just see what it says. Breaking down HTML caching. The problem: your HTML file is this. We are requesting a link, script, and an image. What happens when you deploy a new code? Syntax.html reference styles, blah blah blah. User visits HTML caches for 1 day. So if you visit the website, your index.html and your CSS files are going to be cached for 1 day. So then you deploy update the new HTML references, the new style sheet, not the old style sheet. User browser still has old HTML cache. Now this is the issue, because your new HTML, there is no new HTML. Your old HTML is pointing to the new style sheet. So website is broken. The solution: short cache or smart validation. There are total three approaches. No caching, always fresh but slow. That means you will not face any issue, but user will have to wait for your website load every single time. Okay, so that's the first solution. Second is short cache. You maintain cache for 5 minutes maximum, and after 5 minutes, the cache itself goes invalidates, and that is fine. So the third one is smart validation, e-tag last modified, best of both. So understanding request and response header, the full flow. We make a request to the server responds with 200 ABC, whatever we get, e-tag as ABC. And last modified, server response with last modified at some time. And cache control max age is equal to 300. This is in seconds. So 6 5s are 30. This means 5 minutes. So browser saves HTML content e tag last modified. Second visit, after 5 minutes, cache has expired. So it makes a request again, and it checks what is if none match ABC. Okay, if none matched, if modified since. Okay, if not modified, 304 not modified, no body, use cache version. Okay, not modified. If modified, status 200, new hash, e tag, and basically it means the way the request is being served. If some asset is changed and the e tag it if some asset is changed, then its e tag will be modified with a new hash. I think that is what it means. E tag deep dive. E tag unique identifier for the file. Think of it as like a checksum for the version. Yeah, that is what it's correct. So e tag is like a hash for the file content. So if the file content changes, the server is going to respond with a different e tag, and thus the browser will know to invalidate the cache, and it will render then that new content instead of rendering from the cache. So that is the invalidation strategy. How to work? First request get first example.com response e tag content cache control max age 300. That's fine. Second request after cache expiration, whatever we get index HTML HTTP 1.1. So let's just go back and see the the status of the chat. Actually, I've not even seen the, yeah, this was not, where is OBS? Yeah, there is OBS. So I do not have any idea how do you control this out studio mode, and I have no idea. Let's just go back to seeing the chat in the live stream. When viewers, there is only one was viewed within it was live. Yeah. Okay. So it's 38 minutes down, and let's just complete what we started actually. Just go back to cache. Okay, so that is what e tag means. So let's read this out for the reference that whenever the resource changes, a new e tag value must be generated. On subsequent request, the browser sends the e tag value through the if non-matched request header. If the e tag on the server matches the one sent by browser, the server responds with 304 not modified response. And the browser uses the resource from the cache. While this still incurs network latency, a 304 not modified response is much smaller than an entire HTML resource. However, the network latency involved in revalidating a network freshness is still its own sort of downside. As many as other aspect of web development trade-off and compromise are inevitable, it's up to you to figure out the additional effort. I just forgot one thing. Give me a second. I have to drop a message actually. So that been done. Let's go back, see the stream. No more distractions, I promise. No more distractions, no replies, nothing. So whenever the resource changes, we understand this part. Let's go back, learn performance caching. So we did this. Is it interactive? So it says learn performance caching. So we have this demo utilizes e tag to check the freshness of server response. The page response will include a e tag header and which the browser will store locally and including successive responses through the if none match header. The first time you visit the website, the browser does not have a e-tag value stored locally and therefore receives the full response from the server, including the e-tag value. The tag value is unique for this response, and in our example, it changes every 60 seconds whenever the server time is updated. Now that we also include the cache control, no cache response header, the instruct the browser it may store the response in the cache, but must check the validity of the cache data with the same origin with origin server before using it. Kind of complex to be honest. The browser will store the retrieved e tag and every subsequent request will send the e tag value in the if none matched. The unmatched header sent by the browser matches the e tag value generated by the server. Then the server will request with the 304 status code. So does that mean that initially the if none match header that is being sent by client as include subsets through? So initially the if none match header does not have any kind of value in it most likely, and after some time it will have the value that once you request it again. So I want to check the same thing. Let's just go to a very simple website and try to see if that is actually the case. So let's go to example.com. That is the easiest website I could think of. So this is the example.com domain. It does not even have HTML. So it is giving 307 response and request headers. So in the request headers, I want to see cache control, no cache, pragma, and last modified sinks, right? Last modified, what was it? What was the header name? That is bad. If none match, right? If none match. Okay. Where is it? I cannot see it. General. Mm. So this is the e tag that we have. Let me reload it again. I'm not going to disable cache. Let me enable cache. So this is the first response that not modified. That this is what it is saying, that not modified. So whatever value you have, that this value we were having is still not modified. Let me actually reload this entire page. It's still going to say not modified. Let me clear the site data and see the site uses no data. Let me reload this in a new tab and see the same behavior, example.com. So it made a 200 call from the disk cache. That is okay. And the e tag is not modified. Okay. And let me reload this. And this time we are going to get a status of 304 saying that it's not modified. There we go. We have a status of not modified. And this is actually server sent a request for this particular website. And with the request header, we had our if none match. This is what it meant, if none match. Initially, we do not see this. And later on, this if none match is being sent with every request. So let me just load it again to see that does the 200, does the initial request have that header? That is what my doubt is. And no, it does not have. The request header does not have. As you can see, initially the request header does not have that particular header, but later on it has, in the request header it has if none match. And this is what the e tag concept is actually. And that's it, one down. So pretty hard concept, to be honest, not easy to grab at all. So caching strategy has last. The first we understand the e tag. First was no store. Was this instruct the browser to not cache the response. This is the first. Second is e tag. We now know what is e tag and how it is working. Third one is last modified. If the browser stores the last modified data and includes it on every single request, if data is older than if modified since, then the request will respond with 304. Okay, so it is like, okay, so we have the first request, and this is what the last modified value is. And what was this request? I think this was 304. Yeah. And here we have last modified since. Okay. So I think in this particular context, we are just checking between if modified since and last modified and invalidating the cache. I don't think so there is much to learn in this case. We'll just read this out one more time. The demo utilizes the last modified response header to validate the freshness of the server response. Similar to e-tag, the first time you visit the page, the browser receives the full response from the server. The response includes the last modified header containing the date when the response was generated. This should match the timestamp shown above. Okay. Of the server, similarly, tag first and result of plugin. The response includes the last modified header containing the date when the response was generated. This should match the timestamp shown above. So we store the request received last modified date and include on every subsequent request using the if modified since header. The data is older than if modified since. Okay, yeah, of course, this is the browser working, that is fine. And the last caching strategy we have is max age equal n. Directive instructs the browser that it can cache a resource for in seconds and reuse it for subsequent requests without require revalidation. So whenever we have this max age as 30, after n seconds have elapsed, the browser will make a network request including the okay, this allows you to combine max age with dicer to find a balance between moments of freshness. For example, since the data changes every 60 seconds, using this means that the user could retrieve stale data for maximum of 30 seconds. So this is what the code part is. We are getting some data 304. Okay, return plan. So caching strategies are down, and I think it contains a large chunk of the front end development. And it's been asked in multiple interviews, to be honest. I was asked this particular question about caching strategy, and it decided my fate as between SD1 and 2 when I was interviewing for Pine Labs. So you should not uh, take this granted. This can actually make a difference between SD1 and 2. And since I'm actually trying to be good at both front end and back end, so and I just don't want to be at the SD1 level anymore. So I'm just leveling up my skills and thus this whole study stuff. So if measures server response time. If a response is not cached, the server response time is highly dependent on your hosting provider and backend application stack. Yeah, that is what I said earlier. A web page that serves, okay, this is all just repeating in nature, that is fine. If the user is experiencing a slow fail, you can expose information at when where the time was spent on the server through the use of server timing response header. Can be then collected from in the field using the narration timing API and analyzed to see if user experienced delays. The user, which took 55 milliseconds, database access time, which took 20 milliseconds. You may also want to review hosting infrastructure and confirm that your dedicate resources to handle. Basically, it means that your server should be your server is the one that is responding to this request, and it should be in a good state. And if it's not in the good state, you can use this particular flag, the header, uh, to in the responses actually. And actually, I've not seen much with the server timing, to be honest. I'm just going to ignore it for now. The next thing we have is compression. And actually, this plays a vital role, to be honest, with the response of your website. It depends on what kind of website you have. If it is a text heavy website, then definitely compression is going to save you. Is going to save you a lot if you enable compression in the settings. I think Nginx and other, let's say Nginx, Apache, or whatever server you are using, they have this kind of built-in stuff in it. I'm not sure, but most likely they should have the Plotly and gzip, whatever compression algorithm that you're using built in internally in their server, because these are just servers, right? So does Nginx support uh, and Apache support broadly or web asset compression. They do support it. I'm pretty sure they do support it. I'm just confirming it for you. Broadly is a modern compression. Yeah. gzip is supported. Broadly is not supported. Yeah, gzip, I've seen gzip and deflate, not deflate with this. Native support. Apache does support broadly and gzip both. In the nginx built-in, we can have this gzip flag, enable this particular flag, and we might require to additionally add this particular uh, package as well, but it does support it, right? So we can have this gzip, and in the and Apache is both supported. I think this is good enough for now, that the knowledge that we are getting for the compression, that we can use broadly when possible, and broadly supported on all major browser. And can I use broadly? Yeah, I think anything above 96 was the benchmark we used in our old org, but I think 95.68 also is pretty good score. Internet Explorer is, we just ignore that. Opera Mini and Internet Explorer, just ignore those stuff. So apart from that, we can use broadly whenever possible, but it's not supported in Nginx. So be sure to check out Apache for that if you want. File size matter. Very small resources, less than 1 KB, don't compress very well, or sometimes don't even compress well. So larger the file is, the better compression works. So don't ship very large resources for the factory. So okay. So if your file size is very small, it's not going to affect a lot. I mean, even if you compress it out, it's not going to matter a lot. Let's just say you have 100 files, and each of them are 1 kilobyte. Then, and let's say you compress and the compression rate was 50%. You compressed it, and now the leader file size is going to be 50.5 KB, and you're just saving 50% of the bandwidth. Like maximum you're saving is 50 KB of bandwidth there for 100 file. And let's just say you have two files which are very heavy in nature. Let's just say 400 KB to 100 KB, and that if you try to compress it out large file, it's you are going to get a better fruitful results. Understand dynamic versus static compression are often approaches to when the resource should be compressed. Compression a resource at time is requested and something's okay. On the other hand, compression compress ahead of time. Question to be formed. Static compression removes the latency. Okay. Let's distinguish the specialty for the data should be done. So this actually is a very good point, that it is showing that whatever static resources that you use should be compressed on before end, and whatever HTML files are getting generated, and specifically these are dynamic files dependent upon the authenticated users, then this should be compressed dynamically, and I think that is the case. So we understand this CDN, we know what is a CDN. uh, so okay, CDN is distributed network of network reaching and central server physically. Basically this is just what the backend CDN is, nothing much. You can read about CDN later. I'm not going to explore into CDN. Basically, if you have a server at your origin, let's say I live in Bangalore, and I have a server right here, and I configured a CDN network with multiple server. What it means is, even in Mumbai, I have a server, and if some user is requesting in Vashi region, then his request is going to go to the Mumbai server, not to the Bangalore, reducing the latency. And that is what we want. We want to reduce the latency, use HTTP 2 standard, 3 standard, use caching, use compression, so that everything adds up to make the request faster. So what is a redirect? What type of redirect is completely within your control? A cross origin redirect. Okay. Same origin redirect. Yeah, of course. Not of course. The cross origin is a different stuff. Time header can contain multiple metric. Yes, it can contain multiple metric. Your website origin at servers. So that is it. This is a mistake. Actually thought I didn't actually read quite well, but it's fine. So that sums up the HTML performance considerations, understanding the critical path. So this is a topic on itself. So we can take a break for now. And I'm not sure how do we take a break in this. So what I'm going to do is I'm going to play a video while I take 5 minutes rest probably. So let's go back to OBS. I'm going to add a video source, capture device media source. I'm going to play a local file that I have created in DaVinci yesterday. So we'll go back to Guy YouTube KitKat. There you go. Loop. I'll be back in 5 minutes, but for now, you can have this as media source. Do we have, or instead what I can do is just delete it out and remove my cam. First of all, cam gone. Then go back to the screen and just open up the Finder, because I'm just going to be back in few minutes. So might take 5 minutes for me to get back. I just need to drink some water, have some stuff, but I'll be back. So this is the cheapest way I could think of. So the break time is over. You can just grab once. Yeah, just get back to the code, to the stream. Was it going? Yeah, it's still going fine, right? Only one concurrent user. Okay, so let's just not think about it and continue the study. So the next topic is understanding the critical rendering path. So again, I learned this topic and I completely forgot, and now I'm reiterating over it. So the critical rendering path refers to the steps involved until the web page starts rendering in the browser. To render pages, browser needs to reach the HTML document itself as well as the critical resources necessary for rendering that document. Getting the HTML document to the browser was covered in the previous general HTML performance consideration module, and however we need to look browser what the browser does after it downloads the HTML document in order to render the page. So progressive rendering. The web is distributed by nature. Unlike native applications that are installed before, browsers cannot depend upon websites having all the resources necessary to render the page. Therefore, browsers are very good at rendering pages progressively. This is a great point. What it's saying is browsers cannot depend upon websites having all resources necessary to render the page. Therefore, browsers are very good at rendering pages progressively. Your whatever website you visit is going to be loaded progressively rather than completely all at once. That like it's not something like the entire build is generated and in the browser itself, and you're going to see entire website as one. It's going to render as the DOM is constructed. For the web pages and web lines, the lines between these two pages are much more distinct, and browsers have been specified design with that in mind. Once the browser has resources to render a page, it typically begins to do so. The choice therefore becomes about when to render. When is it too early? If the browser renders as soon as possible, then it has some HTML, but before it has any CSS or necessary JavaScript. Then the page will momentarily look broken and change considerably for the final render. This, which is worse experience than initially presenting a blank screen for a time until the browser has more of the resources loaded into initial render that offers a better user experience. That's a very good point. Meaning that if the HTML is if the browser decides to load the HTML as soon as it has come, it's there, it's from the server. Then the CSS is not loaded for the HTML to look nice, and thus the page is broken for a momentarily time. That is what this particular sentence is saying. On the other hand, if browser waits for all resources to be available instead of doing any sequential rendering, then the users will be left waiting for a long time, often unnecessary. So if the page was unusable at much earlier point in the time, I want to actually, yeah, the browser needs to know what's the minimum number of resources it should wait for in order to avoid presenting an obviously broken experience. On the other hand, the browser also shouldn't wait longer than necessary before presenting the user with some content. The sequence of steps the browser takes before performing the initial render is known as critical rendering path. Understanding the critical rendering path can improve web performance by ensuring you don't block initial rendering any more than usual. Sorry. At the same time, however, it's important to also not allow rendering to happen too early by removing the necessary resources for initial render from the critical rendering path. So this is the exact step that CSCRP takes, that constructing the DOM element. First the DOM is loaded, then the CSS is loaded, then JavaScript, applying in JavaScript that alters DOM or CSS form, that is CSS object model. Construct the DOM tree from the DOM and the CSS DOM. Perform style and layout operations on the page to see what element fits where. This was the question that was being asked in my Minelabs interview for front-end engineer. Actually gave interview for front-end, then promote, got opportunity as full stack there. So this was the question, one of the question that was asked in the first interview, that what is a CSP, CRP. Perform certain layout operations on the page to see what elements fit where. So first DOM is loaded, CSS is loaded, then constructing any JavaScript that alters the DOM. Okay. Constructing the render tree from DOM and CSS. So we first construct HTML DOM, which then constructs CSS DOM. Then we apply JavaScript to see if there is any alter, like if some color is been shifted, something like that. Then construct the render tree from DOM and CSS DOM. Then the render tree is constructed, perform style and layout operations on the page to see what elements fit where. Okay, that is the flex and all those calculations are done in this particular step, most likely. The paint the pixels of the element in memory. Okay, this is the back of the Chrome stuff. We don't really see. Composite the pixels if any of them overlap. Physically draw all the resulting pixels to screen. This is what the structure looks like. HTML DOM, CSS DOM, JavaScript is all constructed into a render tree. Then the style is loaded, layout shift, whatever the layout changes are done. Then this paint and composite are done back in the behind of the scenes. We don't even notice them. And then it is being displayed to the user. This actually reminds me of one project. No, not the project, the React Native internal working. Yoga. Yeah. React Native actually uses this particular thing called as Yoga, I believe. Yeah, meta open source. See? So this has, I mean, if you go into the internals of this, you will understand how it decides to place every node with respect to each other. That if you give position absolute, width like this, height like this, flex direction, align items, this internally handles all that stuff. And this is open source. You can actually see the documentation of the yoga itself, how it constructs. It will give you a similar idea that how internally in the web things can be rendered, and they are rendering. It's like that. So actually read this when I was a few years back. Now I do not have any idea about yoga, but I just remember the project name, to be honest right now. I have to see this as well, but I'm not going to go into the React Native stuff. So let's go back. What resources are there on the rendering process happens multiple times. The initial render invokes the process, but as the more resources that affect the page render become available, the process will in this process or maybe just part of it to update what's the user sees. The CRP focuses on the process previously outlined for the initial render and depends on the critical resource necessary. The browser needs to wait for some critical resources to download before it can complete the initial render. The resources include part of HTML, render blocking CSS in the head element, render blocking JavaScript in the head element. As soon as the browser gets any portion of the HTML pages HTML, the browser starts processing it. Well, then often does decide to render it well before receiving the rest part of it. For the initial render, the browser will not typically wait for all the HTML fonts, images, non-rendering, blocking the script outside of the HTML. For example, script element plays at the end. Okay, so it means if you place your script inside the head tag, it will be part of the first. It will be part of critical rendering path. But if you place your script in, if you write some script and do not place it in the script in the head of the HTML, then that will be non-render blocking the outside of the. I mean, it won't be affected. So the browser will not wait for all the HTML fonts, images, or the scripts that are within the head, outside the head, or the CSS, reading CSS block outside the HTML attribute. Fonts and images are getting or often regarded as browser as content that to be filled during subsequent page re-renders. So they don't need to hold up to the initial render. That is true that sometimes we see that your website is loaded with some different font and later on it is loaded with a different font. This can be, however, mean the areas of blank space are left with initial render while the text is hidden, waiting on fonts or until the images are available. Worse still, it still is when sufficient space is not reserved for different types of content, particularly when the image dimensions are not provided in HTML. The page layout can shift when the content loads later. This aspect of the user experience is measured by CLS. We have discussed this out early. The head that, and one more thing about CLS is let's say if you are making a website and in that website you want to render some kind of ad, right? So the best option that I can think of is construct the size of the ad that you want to render, and you have to pre-calculate the size of the ad for that device. Otherwise there is no way that your otherwise you're going to have CLS issues. That is what I mean. Need to bring some water. Some resources are deemed too critical that the browser pauses page rendering until it has dealt with them. CSS falls into this category. So these are render blocking resources that whatever you place in the CSS is going to render first. The browser avoids rendering any more careful content until it's completed downloading and processing the CSS. CSS is actually the biggest bottleneck for rendering, you can say, that it has to be rendered. Otherwise, your HTML content is just going to look like 1973. Just because a resource block renders does not necessarily mean it stops the browser from doing anything else. Browsers try to be as efficient as possible. So when a browser sees it needs to download a CSS resource, it will request it and pause rendering. But it will carry on processing the rest of HTML and uh, look for other work to do in the meanwhile. Render blocking is like CSS used to block all rendering the page when they discovered. This means when blah 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 some browsers the block render of the content below. Okay, this is pretty useless for us, to be honest. A more recent innovation in the blocking equal render attribute added to allows developer explicitly mark a link so less rendering blocking until the element is processed, but still allowing the parser to continue processing the document in the meantime. So actually want to summarize this up because I don't want to miss anything. So I'm going to pass this to Chrome, summarize the info into easy manner. But actually, it's already written in the easy format. I'm just asking to make it much easier for me to understand. So simplify it. Render blocking CSS, browser is frozen and does nothing. Render blocking CSS, browser pauses painting but keeps working behind scenes. What the browser actually does. Think of browser like construction crew building a house. Painter, I'll wait here, rendering paused. Delivery, I'll go get the CSS, download starts, render. Reader, I'll keep reading the blueprint, HTML parsing continues. Found images, I'll fetch those two, preload other resources. So I'll wait here, rendering paused. I'll go get the CSS, download starts. So when you request this particular link, rendering is paused for that time, and then the download of this particular resource, wherever we requested, is done. Then there is HTML parsing is continuing it in the background. Whatever, I mean, it is paused for this. The painting is stopped, but the parsing is still continued. Okay, these are two different steps. One is parsing, and one is painting. So rendering and parsing are two different stuff. We are in parsing, we are just going to the HTML line by line and continue to parse it. We are not going to paint anything, but but since we don't want to stop the work that we can do, that's the reason why HTML parsing continues. Found images, I'll fetch those two, preload other resources. Only the painter stop, everyone else is working. So that is the very good thing that I didn't knew. Modern browser behavior, old days, blocks entire page. Okay, can't render, and can't render. The modern browsers, Firefox first, now Chrome 2. If this is blocking, this and this renders, the link is blocking, but this and this cannot render because it blocks at this point. Top result shows immediately, bottom waits. Location matters. CSS in head is equal to still blocking everything. Okay, so if you have CSS in head, this is above all content, so it effectively blocks the entire page. Everything below is blocked because it discovered before any content. So nothing can render until it loads. CSS in body equals only blocks content below. So that is a critical difference, and that's the reason that we have the link attribute, whatever style sheet we want to add, in the head, not in the body. So that's a big difference that I know the answer now. So the blocking equal render attribute available in Chrome 105, Firefox 116 plus. What does? Gives you explicit control over the block rendering. Make something render blocking. If you want to, the JS will normally not blocking rendering if it has deferring. Now it will block rendering until loaded. Okay. So if you want to load JS, this I don't think so. This is a very good way to load JS. It has its pros and cons, to be honest, and I can think of reasons why this can be a bad idea. SRC critical JS defer blocking equal render. The JS would normally not block rendering if it has defer async. Let parser continue. Parser keeps reading HTML. Okay, visual timeline it's showing. HTML starts loading. Found CSS in header. Browser downloads. Browser appears frozen until the user CSS loaded. Everything renders at once. With modern browser optimization, HTML starts loading. Found CSS in head. Parser continues. Find images starts downloading. Header content ready renders. CSS loaded. Rest of the content renders. Critical. Render blocking is not equal to browser frozen. Rendering pauses. Parser continues. Download continues. I mean, it's the same thing that I told earlier. The modern browsers are smarter. Definitely, they are. Practical advice: do and don't. You don't want to add huge CSS in this because it's going to be blocking, and you don't actually want to add styles later. Okay. Inline critical CSS. These are inline critical CSS. Load rest later. So that's a really good way to actually make websites, and I think this is what is being used by multiple companies. When you see there is an initial style sheet, and inside the style sheet you have limited. I think the same approach is being used by Carvel itself. Let me just go back, and I just remembered something I wanted to check. Are they using the same stuff? Let's ignore the body, meta, and I think our entire oxygen, yeah, style data CSS. There we go. So these are the atomic classes, and these are the counter hash that I developed for Carvale, which is there. I mean, me and one of my friend. So, so this CSS, this critical CSS is loaded, and this is the atomic classes. So these are loaded first, right? So that is what it means. So that is the reason why we have a style sheet right here, and then these are all the styles that are required in the script tags. But if we have any more styles, we can add them after uh, loading this style, after loading this particular CSS. See, after loading this particular CSS. Okay. So we don't have any more right here. Link is equal to, okay, there are no more style sheets, but if you want to add it later, not earlier. So that is a key takeaway from this particular blog, that this particular reading that I just know. Browser is smart and multitask, but the painter renderer waits for CSS to avoid showing unstyled content. Okay, it's pretty smart, and we can continue to the next point. Parser blocking resources. Parser blocking resources are those that prevent the browser from looking for other work to do. By continuing the parse, the HTML JavaScript by default is parser blocking unless specifically marked as synchronous or deferred. The JavaScript can change the DOM or CSS upon its execution. Therefore, it's not possible for the browser to continue processing other resources until it knows the full impact of the requested JavaScript on a page's HTML. Synchronous JavaScript therefore blocks the parser. Parser blocking resources are effectively render blocking as well. Since the parser can't continue past a parsing blocking process until it has been fully processed, it can't access and render the content after it. The browser can render any HTML received so far. I'll be back because I just found a bug. I need to remove that bug. Just a minute. So this is going to take 1 minute. Be back. Come. So back again. So actually, I found a bug in my desk and I had to clean it out. So that was the emergency, top level emergency. So just read this out, or what we can do is to simplify and save our time. Go back and ask it to do the same thing with what it did earlier. So simplified. Will pause, painting, reading, painting, downloading, limited, full stop. You can't even read ahead safely. Parser blocking is worse. Why does JavaScript block the parser? The problem. JavaScript can change anything on the page. Okay. And this is the code and this is the DOM. And this is JavaScript can modify DOM. JavaScript can modify CSS on. JavaScript can even write a new HTML. What goes in? Browser dilemma. What if I keep reading? The JavaScript might completely rewrite what comes next. Better wait. So that's the best thing browser can do. Just wait. Restaurant analogy, render blocking, CSS, parser blocking JavaScript. Wait. The recipe says if chicken is done, ignore next three steps. I can't even read ahead safely. Everything stops until I cook the chicken and check. Visual timeline comparison. So basically, what it means is if we have JavaScript in it, then it is going to stop the parsing at for entirely because there is no even if you do parse, the JavaScript is going to change the code anyways later on. Let me give you an example from this example itself. So you have your code, you have a div, this was not blocking, and you then got a script. And let's just say this script was loaded from external source. Then the JavaScript is going to stop at that particular source and it's going to do parser blocking. So the later code, so this line is not this line is not going to get passed into not going to get parsed asynchronously. Earlier JavaScript was doing was earlier the browser was parsing this during the render block phase for not for the parser block but for yeah but for this particular step, render blocking resources simplified, this step. But in this step, the next step, it is also going to do parser blocking, which is worse. Because if let's say at this point it continues parsing and because of this script getting executed, it changed the content of this entire thing. So this the thing that the work that it did parsing this entire stuff is wasted, and that we do not want, that the browser wants to avoid that. Again it has to go and do the entire work, so it's actually wasting resources than actually optimally using it. So it's better to wait than to continue the parsing. So that is the reason JavaScript is parser blocking. Okay. Okay, so there is actually a way out, it's saying. Let me just read those out. Where can we see? It's a pretty long blog, to be honest. It's a blog on its own. Okay. Preload scanner to the rescue. Model programs have a backup parser called as preload scanner. It works. So we have a slow JavaScript at top. We then have images. Main parser. Oof, blocked by JavaScript. Preload scanner. Let me help. I'll skim ahead. Font images 1, 2, 3. Starts downloading all three. JS main parser. JS done. Oh, nice. Everything's ready. Okay, so basically it has two parsers, not one. Earlier we only had one, and if the JavaScript was parser blocking, we cannot do anything later on. But now it can at least download the resources ahead of time. It's not scanning for the divisions, I think, and I don't think so. That makes sense. How to avoid parser blocking? So preloads cannot find dynamic content, can't predict this, so preload scanner is going to avoid this stuff. Not found. Images in CSS aren't discovered until CSS is parsed, so that is one bummer. And how to avoid parser blocking? Bad blocking JavaScript. If you have blocking JavaScript, parser is blocked. Good is asynchronous JavaScript. Downloads in parallel doesn't block parser, executes when ready. So this is actually a good way to do it, but again, using asynchronous comes with the cost itself. So be sure with that. Found JS async, download some background, parsing continuous, found images, JS download, finish download, execute. Doesn't block parser during download. Defer JavaScript. Defer is actually better, and definitely it is better because we are now telling it to do it in end, I guess. Visual browser continues found the defer JavaScript downloads in background. Parser continues HTML fully parsed all images found and downloading. Now execute the deferred JS. So everything is downloaded. HTML. What is the difference actually? What's the difference between these two? Synchronous JS downloads in background. Parser continues. Found images download starts. Parser continues. JS finishes download executes. Found defer JS download in background. Parser continues. HTML fully parsed, all images found and downloading. Now execute the defer JS. So JS is going to get executed it and doesn't uh, block parser during download. So they both do not block. I do not get the difference between async and defer now. Downloads immediately, parallel, when ready, and after HTML. This is the basic difference. Order guaranteed, yes. Defer guarantees the order. And why does it matter? Okay, so it's more of whenever we get JavaScript. Uh, okay, understood. So it's more of the way the resources are downloaded and executed. In the case of async, there is multiple files. If they have a sync tag, they are going to the order of the execution going to get messed up because it can happen that first script can execute first, which came first due to the download speed or something like that, or the way browser is requesting. And for the async one, we cannot guarantee the order. That is correct. For the defer one, we can guarantee. We just add defer at the end, so it is guaranteed that that script is going to run last. It's something like that, I guess. Uh, Defer versus async. Let's just read that out as well. And let's just confirm that whatever understanding that I hold is correct. The way blocking, this is blocking, this is async, download execute, parser block during execution. Parser is blocked during execution. Parser never blocked executes after HTML done. Execute the script, parser still blocked, parser resumes. Parser hits the script tag, starts download in the background, parser continues. When download completes, pause, parser, execute immediately, parser resumes. Font script starts download, parser continues, still parsing. Script is downloading background. In this case, it's was parser, execute immediately. Okay, so it's just the way the context which is happening between the parser and the executor. And in this case, that is fine. Understand that your still parser continues, still parsing parser, still downloading background. When the download is complete, we pause the parser in case of async, and we start executing the script, whatever we have. When the execution is complete, then the parser resumes. This is a really good, solid and understanding that I'm getting for async and defer. Parser hits the script tag, starts downloading background. Okay, parser continues. When the HTML parsing completely done, then we execute script. Download parser continues. Still parsing. Script downloaded in background. Downloading in background. Script download complete, but doesn't execute yet. Parser keeps going. HTML parse complete. Now execute deferred script. So this is the main difference. The way the context switch between the parser and the execution phase is happening. And I think defer is definitely solid in that perspective. It's better than the async tag because of that reason. So that I understand fine now. I can die finally because of I understand parser blocking resources. So this is fine. Identify blocking resources. Yeah, this is what we saw in the web page test. So this is what they are promoting, yes, definitely Google to promote a third party site. This is not something you expected. So just like GT metrics, you can see the waterfall model, see the what are the problems that we are having. Optimize the critical rendering path. Optimize the critical involves reducing the time to receive the HTML, but and detailed place model and impact. Okay, steps are investigated in next module. The critical contentful rendering path. This is a different thing. And the critical has concerned itself with the initial render. However, a more user-centric metric for web performance has emerged, which has some questioning whether the endpoint of the critical rendering path should be the first paint or one of the more contentful paints that follow afterwards. An alternative view is also instead concentrate on time until LCP or even FCP as part of contentful rendering path, the key path as the other might call it. In this case, you might need to include resources that are not necessarily blocking, has been typically definition of CPS that are necessary to render contentful pages. What you define as critical understanding what holds upon initial render and your content design. So it's first possible opportunity to render anything for the user. Ideally, there should be something meaningful, not something like background color. Not something like background color. Uh, for example, but even if it's non-contentful, there is still value in presenting something to user. It is an argument for measuring the critical rendering path as the traditionally defined. At the same time, there is also value in measuring the main content is present to the user. I'm not sure if the stream is working. Let me just verify. Yeah, I think this is working fine. The stream itself is working fine. So let's just go back to the chat and see what we can do next. Okay, so this is working. I saw it in phone, so that is fine. Then we identified the critical contentful rendering path. And what was it earlier? Okay, identify the contentful path. We saw this. Okay, what is the critical render path referred to? So okay, this is fine. I guess we don't need to. We can just test the knowledge. What does the critical rendering path refer to? Amount of render to perform the initial render. Yeah. What resources are involved in the critical rendering path? Okay. Render blocking JavaScript in the head element part of the HTML. Render blocking CSS in the head HTML script. One of three correct answer part of HTML and render blocking CSS in. They should not actually give this particular thing because that way I know that every answer is correct. So render blocking CSS in the HTML element correct. Why is render blocking a necessary part of page rendering? Seeing a page to prevent a page from initially rendering in a usable or rapidly broken state. From seeing a page until it's completely rendered. I think this is the correct answer for this. What does JavaScript block the HTML parser? The aren't specified on script element. Must be without at least one of these attributes blocking and render blocking. All JavaScript is parser block regardless of those attributes. No, this is not correct. Synchronous JavaScript must be executed when the parser reaches it, as it could change the DOM. think this is the correct answer and this is the correct answer. Without at least one of those attributes, a script is parser blocking and render blocking. Definitely that is the case, because if you don't define one of these attributes, the entire script is parser blocking and render blocking both. Okay, so that being said, we correctly gave the test, and this is where I think I'm going to stop for the day. Let's continue this entire journey that we have and to the next day. So let's continue this tomorrow, and actually have an interview coming up in morning. So I have to probably do DSA for it. I don't actually want to do DSA, but yeah, I might have to revise it. So it's time to go to bed. So see you guys in the next one. It was fun doing web optimization with you guys, and I think this is a pretty great resource if you want to learn about web, how the web works. So web.dev, created by Google, I guess, is a really good site. So that's it for the video. Have a great day, and bye.